Hi everyone. So welcome to lecture number 9 of counting course. We are doing as part of GATE Data Science and Artificial Intelligence complete course. So in this lecture we will see the principle of inclusion and exclusion. It is very core and fundamental to counting in general. So we will see this principle. Firstly, talking about the motivation. So the motivation of inclusion and exclusion comes from set theory. So let's say this is our universe, and I will use a few terms from set theory right now. Okay, so if you don't know set theory, it's okay, but still you will understand the concept which I'm trying to say. Okay, so this is our universe. Let's say this is my set A and this is my set B, and set A contains n elements and set B contains m elements. Okay, then the union of these two sets. Okay, the union of these two sets is called like how many elements are there in A or B. That is what union is. Like they can be in A or B. Okay, anyone. So the cardinality of A union B here is n plus m because A and B are disjoint. So A and B, since don't have any elements in common, the cardinality or the number of elements in A union B will become n plus m. Right? All the number of elements in A and n in B. But sometimes there might be a few elements common in A and B. So let's say this is my set A, this is my set B, and let's say there are a few elements. Let's say there are n elements in A, m elements in B, and there are k elements which are common in both A and B. The common part is called A intersection B. Okay, the common part is called A intersection B. So the cardinality of A intersection B right now, let's say, is k. Okay, there are k elements which are both in A and B. There are overall n elements in A, and there are overall m elements in B. Okay, so in this case, the cardinality of A union B will be what? So it will be n plus m. N plus m is okay. Okay, n plus m is what? Counting all the elements in A and counting all the elements in B. But here, few elements we are overcounting. These k elements, if you see, these k elements, we are counting in both A and B both, right? So we are counting them twice. So since we are overcounting, we will subtract these k elements once. Since we counted these k elements two times, both in A and B, we have to subtract them once because that's what we want. So for example, let's say in the same example, let's say A has here 1, 2, 3, 4, 5 elements, and B has 3 elements, 1, 2, 3, 4, 5, and this is A, this is B. So here A has 5 elements, the dots, and here B has 3 elements. But there are 2 elements which are common in both A and B. So the total number of elements in A union B is what? We can count them. Like here there are 1, 2, 3, 4, 5, 6 elements. But from the formula we will have cardinality of A plus cardinality of B minus cardinality of A intersection B, which is 6. Okay? Since we were counting these 2 elements 2 times, both in A and B, we have to subtract it once. This is what the principle of inclusion-exclusion is. Since we overcounted, we are excluding them. But so if you are only excluding, why are we calling it inclusion-exclusion? So that thing will become clear when we see more sets. Let's say let us take 3 sets now. Okay. So if I take 3 sets, this is my set A. Okay. So here the cardinality of A union B union C will be what? Let's try to find out. It will be the cardinality of A, the number of elements in A, plus number of elements in B, plus number of elements in C. This is okay. But right now we are overcounting. So what we are doing essentially, So when we are adding all the elements in A, B and C, this particular area which is in both A and B, this particular area which is in both A and B is counted in both A and B. So it is counted two times. So we have to subtract it once. So we will subtract it once. The area which is in both A and B, since we counted it 2 times. Similarly, this particular area which is in both A and C, this is also counted 2 times, right? So we have to subtract that as well. That is also counted 2 times. And also the area which is in both B and C, the area which is in both B and C, that is also counted 2 times in B and C both. So we have to subtract that also once. Okay, but now one thing happened. So what happened is, this particular small area, which is in all 3, this particular area is like present in all the 3 sets, A, B and C. So what happened to this area? Think about it. This was counted once in A, it was in A, it was in B also, it was in C also, right? So it was counted 3 times. In these 3, it was counted 3 times, this particular area, because it is present everywhere in A, B and C. It is also present in A intersection B. Here also in A intersection B also it is present. In A intersection C also it is present, and in B intersection C also it is present. So this area is added 3 times and subtracted 3 times, right? So basically right now, if the formula had been just this particular area is not present at all. It was added 3 times and subtracted 3 times. So we have to add it once. So this is what inclusion-exclusion is. We include, we exclude, and we again include, and so on. If we have 4 sets, we will include, exclude, and so on. That's why inclusion-exclusion, right? So basically what we are doing, keep all the elements which take 1 at a time. Then we subtract the sets with 2 at a time. Then we add 3 at a time. Then we subtract 4 at a time, and so on. This is what inclusion-exclusion is. Okay. So if you take an example like how many natural numbers less than 100 are non-multiples of 2 or 3. So let's say less than or equal to, okay, or we can do less than also, but like yeah, then 99 will be a bad number. Let's make it 101. Okay, how many natural numbers less than 101? So basically I want to include 100 so that the math will be simpler. Okay, so how many natural numbers between 1 and 100 are there which are non-multiples of 2 or 3? What do I mean by non-multiples? They should not be divisible by 2 and they should not be divisible by 3, both. So now very simple, okay? Use inclusion-exclusion. So what do we want? So we want all the numbers which are not divisible by 2 and they should not be divisible by 3. So firstly, how many numbers do I have between 1 and 100? I have 100 numbers. These are all natural numbers. Okay. So I will subtract all the numbers which are divisible by 3, divisible by 2. Let's subtract all the numbers which are divisible by 2. So how many numbers will be divisible by 2? Floor of 100 by 2. So always when you have, like if you want to find how many natural numbers less than n are divisible by k, it will be floor of n by k. Why? See, the first number which will be divisible by k will be k itself, then 2k, then 3k. These are all divisible by k, right? And we have to reach n somewhere, right? So this will be divisible by k, this will be divisible by k, this will be divisible by k. So what will be the last number that will be divisible by k? So it will be somewhat, if n is exactly divisible by k, it will become exactly n by k, right? If n is exactly divisible by k, this n exactly will be my last number, and total number of numbers will be 1, 2, 3 and n by k, right? But it might be possible that n is exactly not divisible by k and a slightly smaller number somewhere here. is divisible by k, and we have to stop there. So that particular number will be floor of n by k into k always. So for example, like up to, let's say if I have numbers up to 10 and I want to find out what are the numbers which are less than 10 and are divisible by 3. So 3 will be divisible by 3, 6 will be divisible by 3 and 9 will be divisible by 2 and 10 will be here. Only these 3 are divisible by 3. So what is 9 actually? 9 is actually floor of 10 by 3 into 3. Because floor of 10 by 3 is the just less than number, like just less than 10, which will divide 3. Okay, so if I multiply it by 3, I will get 9, which is the last number which is less than 10 and is divisible by 3. So if you want to find the number of natural numbers less than n and are divisible by k, it will be floor of n by k. So I subtracted all the numbers which are divisible by 2. There are 50 numbers which are divisible by 2. Now similarly, I will subtract all the numbers which are divisible by 3. So it will be 100 by 3 floor. Okay. Now again inclusion-exclusion. I subtracted all the numbers divisible by 2 and I subtracted all the numbers divisible by 3. But actually I subtracted the numbers divisible by both 2 and 3 two times. There will be few numbers which are divisible by both 2 and 3. For example, 6. So 6 is a number which is divisible by both 2 and 3. It is subtracted here also and here also. So I don't have to subtract them twice. So I will add them once. Include, exclude, again include. So I will include them. So I will include all the numbers which are divisible by both 2 and 3. So, okay. If you have to find out all the numbers which are divisible by, let's say, 10 and 12. I'm just giving you a different problem. Any number which will be divisible by both 10 and 12. Now I don't want to check two numbers, I want to get to one number. So, like I cannot say that all the numbers which are divisible by 10 will always be divisible by 12 also, right? That is not right. And the general mistake which people do while solving this problem is they multiply both these numbers. So they say that all the numbers which are divisible by 120 will be divisible by both 10 and 12. It is correct, but it is not exactly correct. See, there is a one more number. Actually, 60 is also divisible by both 10 and 20. 10 and 12, right? 60 is also divisible by both 10 and 12. So if you have to find all the numbers which are divisible by both A and B, you should find out all the numbers which are divisible by LCM of A and B. Just find out the LCM of 10 and 12, the lowest common multiple of 10 and 12. So the lowest common multiple, like you just do the prime factorization 2 into 5, and here it is 2 into 3. So you just take the common elements out and it will become 2 into 5 into 2 into 3. So it is 60. So the LCM of 10 and 12 is 60. So if you have to find all the numbers which are divisible by both 10 and 12, then you just have to find out all the numbers which are divisible by 60. Okay, all such numbers 60, 120, 180 and so on will be divisible by both 10 and 12. So just find out the LCM. So here also, if you have to find out all the numbers which are divisible by both 2 and 3, just take their LCM, it is 6. So all the numbers divisible by 6 will be divisible by both 2 and 3. So you just have to add them. So 100 by 6. So this will be your answer. So this is 100 minus 50 minus 33 plus 60. Okay. So if you just calculate it, it will come out to be 33. Cool. So there are 33 natural numbers which are non-multiples of 2 and 3. So similarly, we can solve one more problem using 3 sets, 2, 6 and 12. So now the number should not be divisible by 2 or 6 or 12. So again, we have 100 numbers minus those who are divisible by 2 minus those who are divisible by 6 minus those who are divisible by 12. So this is include, exclude. So this is divisible by 2, this is divisible by 6, this is divisible by 12. Now we have to add we have to add 2 at a time. Subtract 1 at a time, add 2 at a time. So you have to add all the elements which are divisible by both 2 and 6. So how many numbers which are divisible by both 2 and 6? The common mistake is you will divide by 12. It should not be 12. The LCM of 2 and 6. The number which are divisible by both 2 and 6 will be divisible by 6 only, because LCM is 6. So it should be 100 by 6. Then you will add all the numbers which are divisible by both 2 and 12. So the LCM of 2 and 12 is again 12. So it should be 100 by 12. Then we will again add all the numbers which are divisible by both 6 and 12. Their LCM is also 12. So it should be 100 by 12. And now we will subtract. So minus 1 at a time, plus 2 at a time, minus all 3 at a time. So we will subtract all the numbers which are divisible by all 3 of them, which means 2, 6 and 12. So their LCM is also 12 only, right? So we will subtract 100 by 12. Okay? So if we do this, this will get cancelled, this will get cancelled, this will get cancelled, and we will just get 50. 100 minus 50 is 50. So it is intuitive also. See, all the numbers less than 100 which are not divisible by 2, 6 or 12. So basically all the odd numbers are not divisible by 2, 6 or 12, right? 1, 3, 5, 7. Since they are not divisible by 2, they will not be divisible by 6 or 12 also. So all the odd numbers are actually the answers. So like you can solve it that way or using inclusion-exclusion. So there are 50 numbers. Cool. So in general form, the principle of inclusion-exclusion states that for finite set A1, A2 up to AN, one has the identity. So this is like the general form. I will write it in a smaller way for you first, then we will see this formula. So basically, the cardinality of A1 union A2. Let's say we have n sets. So the cardinality of A1, A2 up to AN will be what? The cardinality of A1 plus cardinality of A2. So when we are doing this, we are overcounting 2 at a time. So we are overcounting A1 union A2, A1 intersection A2 2 times. In A1 and A2 both. So you have to subtract them. So subtract all pair wise. A1 intersection A2, A1 intersection A3, and so on. Subtract all the pair wise, 2 at a time. So this is 1 at a time. These are sets taken 1 at a time, and then subtract 2 at a time. And then, so what happens? So consider the set A1 intersection A2 intersection A3. A1, A2, A3 all. So it is counted 3 times here and subtracted 3 times here. A1, A2, A1, A3 and A2, A3. So we have to add it once. So we'll add 3 at a time. We add all the sets taken 3 at a time. Okay, and we keep doing it that way, minus 4 at a time, plus 5 at a time, and so on. And at the end, we will have minus or plus, anything might be there. Then we will have all the elements at once, n at a time. See, when we had 1 at a time, we have a plus sign. When we have 2 at a time, we have a minus sign. When we have 3 at a time, we have a plus sign again. So when we have n at a time, this is n at a time. What will be the sign, plus or minus? So how to write it? Always write the sign in this form, minus 1 to the power something. So if I write minus 1 to the power n, what will happen? Minus 1 to the power n is not correct. Because for n equal to 1 it is plus. For n equal to 1 it is plus. For n equal to 2 it is minus. So it should be minus 1 to the power n minus 1. So this is like the multiplication factor I gave. So the last term will be plus minus 1 to the power n minus 1. So this will like automatically adjust. Like if n is even, this will become a negative sign. If n is odd, it will become a positive sign. Okay, minus plus minus plus. So this is our last term. So this is the inclusion-exclusion principle, and it is written beautifully here. So the cardinality of union of n sets A1 union A2 A union A3 is equal to sum of cardinalities of taken one at a time minus sum taken two at a time A intersection AJ for all IJ plus taken three at a time minus plus minus and so on, and the last term is minus 1 to the power n minus 1 taken all at a time. Okay, we just saw it. So now let's solve a few problems. So how many integral solutions does the following system of equations have? So this is the system of equation which is given: x1 plus x2 plus x3 is equal to 10, and all the xi, so x1, x2, x3, all three of them are between 1 and 4. 0 and 4. See, if this condition was not there, less than equal to 4 value, if this condition had not been there, the problem would be much simpler. We already know how many solutions are there for x1 plus x2 plus x3 is equal to 10, where x1, x2, x3 are all greater than equal to 0. It is 12C2, right? Combination with repetition. So we just take 12 boxes, insert 2 sticks, 12C2 solutions are there. Where there is no condition on x1, x2, x3, like this right hand side condition, only this condition is there. So, okay. But now we have a condition. So what is the condition? x1 should be between 0 and 4, x2 should be between 0 and 4, and x3 should be between 0 and 4. Okay. So let's forget this side of the condition. It doesn't matter, right? Let's say we already know the solution, right? x1, x2, x3 have to be greater than or equal to 0. That's the formula we already know. So I'm forgetting about this side of the condition for now. This is the condition that we are worried about. This is the condition that we are. Okay. Okay. Yeah. These are the conditions that I am worried about. Ki x1, x2, x3 should not cross the value 4. See, I already told you if there had been no condition, there are 12C2 like possible ways in which you can do this. One such way is 10, 0, 0. Right? And this is not allowed because none of x1, x2, x3 can cross 4. So we are overcounting. So how will we deal with this with such a situation? So see, what is the counterpart of this? If I want to exploit this condition, if I don't want to care about this condition, then x1 has to be greater than 4. Then x1 has to be greater than 4. Or basically x1 has to be greater than or equal to 5. If x1 is greater than or equal to 5, then this condition is not taken care of. You agree? Similarly, if x2 is greater than or equal to 5, then this condition is not taken care of. Similarly, if x3 is greater than or equal to 5, this condition is not getting taken care of. So how do I do that? How do I solve this problem? So I know that the total number of solutions to this problem is 12C2. Right? Now I subtract all the possible combinations in which x1 is not in bounds. I subtract all the ways in which x1 is greater than or equal to 5. I will subtract all the ways in which x1 is greater than or equal to 5. It means that x1 is not following its bounds. Right? If x1 is greater than or equal to 5, we don't want such solutions. And this problem is easier to solve. So x2 and I don't care about x2, x3 right now. x2, x3 can be anything. Only x1 is not following their bounds. I only care about x1. So how many such values are there? Write x1 as 5 plus a. Write x1 as 5 plus a. So the equation will become x1 plus x2 plus x3 is equal to. So instead of x1 I am writing a. So a plus x1 plus x2 plus x3 plus 5 is equal to 10. So 5 will go there and become 5. So the equation becomes a plus x2 plus x3 is equal to 5. And now a x2, x3 can be anything. I am just solving for this. x1 has to be greater than or equal to 5. So I am writing x1 as 5 plus a. If you are not understanding this, watch my last video, combination with repetition examples. I have solved this there, okay? So how many solutions are there to this equation? 7C2. So there are 7C2 ways in which x1 is greater than or equal to 5. Similarly, there will be 7C2 ways in which x2 is greater than or equal to 5. right? Same way, like with symmetry. Similarly, there will be 7C2 is in which just x3 will be greater than or equal to 5. Right? Now, in how many ways now I will add? I will add all such cases in which both x1 and x2 are greater than or equal to 5. We have to add all such cases in which both x1 and x2 are greater than or equal to 5. So basically x1 also has to be greater than or equal to 5, x2 also has to be greater than or equal to 5. There is only one such way, right? 5, 5, 0. See, anyways, like if both of them have to be greater than or equal to 5, both of them have to be 5. Otherwise, it is not possible. Like, the sum has to be 10. So there is only one such way in which both of them are greater than or equal to 5. Similarly, I will add that value in which both x1 and x3 are greater than or equal to 5. And similarly, I will add all the cases in which both x2 and x3 are greater than or equal to 5. Right? Standard inclusion-exclusion. 0 at a time, 1 at a time, 2 at a time. And then I will subtract all the ways in which all three of them are greater than or equal to 5. Like see, all three of them cannot be greater than or equal to 5, right? x1, x2, x3 cannot all be greater than or equal to 5. Then the sum will not be 10. Because at least the sum will be 15, 5 plus 7 plus 5. So this is not possible. So there are only 0 ways in which all x1, x2, x3 are greater than or equal to 5. Okay, so this is your answer. You can calculate it. So 12C2 is what? 12 into 11 by 2. It is 66. Minus 3 times 7C2. 7C2 is 7 into 6 upon 5. 7 into 6 upon 2. So 7 into 3 basically. And plus 1 plus 1 plus 1, 3. So this is 66 minus. Okay. 63 plus 3. So it is 3 plus 3, 6. So there are 6 solutions to this equation. There are 6 solutions to this system of equations. You can calculate it. And since there are only 6 solutions, you can also like write them down. x1, x2, x3. So since all of them have to be between 0 and 4, let's start with 4. So one such solution will be 4, 4 and 2. Then 4, 2, 4. Then 2, 4, 4. Then let's say I make x1 equal to 3 and x2 equal to 4 and then 3. Okay, so 4 plus 3 is also 10. So then 4, 3, 3. Then 3, 3, 4. So these are the only possible 6 solutions to this equation. Okay, you can check. You will not be able to get any more solutions. So there are 6 solutions. This is how inclusion and exclusion works with principle like combination and repetition. I told you there as well. To solve a generic question, you need inclusion and exclusion. Cool. So thank you for this video. I will have one more video on inclusion and exclusion. So we will upload it tomorrow. Thanks. Bye.